This is Bob Capetta from the College of the Florida Keys, and this lesson is on inequalities. Let's look at strategies for solving them and how we express our solutions. So let's start with something as simple as x is less than or equal to 3. So we want to think about those numbers that indeed are going to be less than or equal to 3. So we can go ahead and lay out our number line. 3 is our point of interest. We're comparing everything to 3. This is less than or equal to, so we're going to go ahead and put a solid dot here. Now, what I like to do is I like to choose points on either side of that 3. So we've got a point to the left of 3 to look at and a point to the right of 3 to look at. To the left of 3, I will choose 0. To the right of 3, I will choose 4. We want to check if these points are true or false. So I have, again, x is less equal to 3, plugging in 0 in for x. 0 is less equal to 3, that's true. Plugging in 4, x less equal 3. 4 less equal 3, that's false. So we shade towards the side that's true, and if we're going to graph this, it graphs this direction towards the true side, and it goes all the way to the end. So that is a graph solution on a number line for x is less than or equal to 3. How far does it go? It ends at 3, but it goes all the way to the left as far as it will go. It goes all the way to negative infinity. So we're going to use this concept called interval notation. The left endpoint doesn't exist. It goes all the way to negative infinity. Since it doesn't get to negative infinity, we make that a round bracket. Its right endpoint is 3. 3 is included. Since 3 is included, it's a solid dot. We will give that a square bracket. And that's what that looks like. And let's look at another one in a similar kind of vein. If I'm going to say 6 is greater than x. So again, my approach is going to be essentially the same. 6 is going to be our point of interest, what I sometimes call a cut point. It is greater than, not greater than or equal to. If it's greater than, we are not allowed to use the 6. We have to stay away from the 6. We'll use an open circle here. And I want to test numbers on both sides. So we'll test a number to the left of 6. 0 is to the left of 6. To the right of 6, I'm going to choose 7. So I'm going to plug these in to see if they're true or if they're false. 6 is greater than x, plug in a 0 for x. 6 is greater than 0, I'm going to just say yes, that's true. 6 is greater than x, plug in 7 for x. 6 is greater than 7, that's no. So we're going to shade to the left, shade towards the yes side. So this will be shaded this direction, this way. So that is the graph solution, graphing your solution set on a number line. Again, it goes all the way to negative infinity, and it ends at 6. But this time, we don't actually get to 6. It's an open circle because there's no equal up here. That will be a round bracket. Let's do one more of those if we can. How about negative 2x is less than 10? What is my strategy here going to be? Well, I'm going to do it as an equal. If I'm working off of inequalities, I solve them first as equals. So I'm going to say negative 2x equals 10 to find my cut point. Like the cut point up here was 3. The cut point here was 6. Finding our cut point here, I have negative 2x is 10. Divide both sides by negative 2, and I get x is negative 5. So if x is negative 5 is going to be my cut point. So we're going to lay out negative 5 in the middle of this number line. It is less than, it is strictly less than, so that is an open circle. And then we've got to find numbers on either side of negative 5. Bigger than negative 5, bigger than owing 5? Well, 0 is always my favorite one to choose. So I'll put 0 on this side. To the left of negative 5, maybe we'll go with negative 6. Let me try 0 first. So we're going to look at negative 2x is less than 10. Negative 2x is less than 10, plugging in 0. Negative 2 times 0 is less than 10. 0 is less than 10. That's true. That's yes. Whereas this other one, negative 2x is less than 10. Plugging in negative 6, negative 2 times negative 6 is less than 10. 12 is less than 10. That's a no. So we're going to shade towards the yes side. We're going to shade towards the yes side. It's going to shade this direction. Yes is this way. In interval notation, what will that look like? We are starting at negative 5, and we are going all the way to the end. Where does this end? This is positive infinity. We never actually get to positive infinity, so we always use round brackets around infinities. You'll notice a round bracket above negative or by negative infinity here, a round bracket by negative infinity here, a round bracket by positive infinity here. The square bracket comes into play less than or equal to square bracket, no equal, round bracket, no equal, round bracket on the number. Okay, let's do a couple more of these if we can. Get my paper straightened out here. Let's take a look at x plus 5 is greater than 1. So my approach is to solve it as an equal sign. X plus 5 equals 1. So we're going to add negative 5 to both sides. Negative 5 here, negative 5 here. And I get x equals 1, subtract 5, x equals negative 4. So negative 4 is my cut point. It's a round circle, a round hole, because the equal is not included. I've got to choose numbers on each side to test. To the right of negative 4, negative 4, negative 3, negative 2, negative 1, 0 is what I'll use. To the left of negative 4, how about negative 5? Then we're going to plug those in to see if they're true. I like to always do 0 first. X plus 5 greater than 1. 0 plus 5 greater than 1. 5 is greater than 1. Yes. Over on this side, x plus 5 greater than 1. Plug negative 5 in. Negative 5 plus 5, is that greater than 1? Is 0 greater than 1? That's no. So we're going to shade towards the yes side. We're going to shade this way. So starting at negative 4, round bracket again. Negative 4 here, going all the way to the right. All the way to positive infinity. Okay, let's do another one. So this time let's go with 2x minus 3 is less equal to 5x plus 1. So our strategy here is still going to be the same. We're going to solve it as an equal, find test points, and then determine which way to shade. So I've got to solve 2x minus 3 equals 5x plus 1. So if I'm going to do this, let's go ahead and make that minus 3 plus negatives. Let's get all of the x's on one side. So let's subtract 5x from both sides. Subtract 5x. Subtract 5x. Now I have 2x subtract 5x. Negative 3x plus negative 3 equals 5x plus negative 5x is 0 plus 1. We're going to solve for x, so we have to add 3 to both sides. Add 3 here. Add 3 here. And I have negative 3x equals 4. And then divide by negative 3. And I get x is negative 4/3. And let's make sure we know what that is approximately. Or negative 1 1/3, just so we know where it is on the number line. So we lay out our number line with negative 4/3 in the middle. And negative 4/3 is our point of interest, and it's less than or equal to, so we will make that a solid dot. Well, to the right of a negative number is a positive number. My favorite number that's not negative is not positive, but instead is 0. And to the left of negative 1 1/3, negative 2, negative 3, negative 4, maybe I'll just choose negative 4. Any number will work. So we're going to check to see which way we're going to have to shade. So if I work with 2x minus 3 less equal 5x plus 1, plugging in 0, 2 times 0 minus 3 less equal 5 times 0 plus 1. 0 minus 3 is negative 3 less than or equal to 0 plus 1. Is that less than 1? Is owing $3 worse than having $1? Yes. So we're going to shade towards the yes. Let's quickly do the other side. 2x minus 3 less equal 5x plus 1. We're going to see if that's true. We're going to plug negative 4 in. 2 times negative 4 minus 3 is less than 5 times negative 4 plus 1. 2 times negative 4, negative 8 minus 3, is that less than negative 20 plus 1? Negative 8 plus negative 3 is negative 11, less equal to negative 19. Is owing $11 worse than owing 19? That's no. And typically one of them is going to be yes and one of them is going to be no. So we'll go ahead and we'll shade the right side there. And then we will express this in interval notation. So starting at negative 4/3 with a square bracket on the left, comma, how far does it go? As far as you can go, all the way to positive infinity. And let's put a round bracket on that side. Okay, let's do another one if we can. How about 2 times x plus 4 is less than or equal to x plus 3 plus x. So my strategy is going to be the same. I'm going to solve it as an equal first and see what happens. So if I solve this as an equal, 2 times x plus 4 equals x plus 3 plus x. I get 2x plus 8 equals x plus x equals 2x plus 3. Well, the 2x's subtract out and I get 8 equals 3. So there are no cut points. So it's never true. It's never equal. Well, if that's the case, I don't have to test 2 of them. I can just test 1 to see if it's true. So there's no cut point. If I plug in 0, so let's plug in 0, see what happens. Plug in 0. What happens here? I get 2 times 0 plus 4. Is that less than? Is that less than 0 plus 3 plus 0? So on the left side, I get 2 times 0 plus 4, I get 8. Is 8 less than or equal to 3? No. So I don't shade anything. If it had been true, I would have shaded everything. But I don't shade anything, so my answer here is no solution. It's not true for 0. There's no other place where the thing is equal. So there is no solution. Empty set, sometimes we use that symbol to represent the empty set. And let's do one more to finish up this video. Let's take a look at negative 3 times x plus 8 minus 5x greater than or equal to 4x minus 9. So my procedure is the same. I'm going to go ahead and solve it as an equal first and then test the points to see what's happening. So negative 3 times x plus 8 minus 5x equals 4x minus 9. So go ahead and change those minuses to plus negative. This becomes plus negative 5x. This becomes plus negative 9, and let's distribute. So I get negative 3x plus negative 3 times 8 is negative 24 plus negative 5x equals 4x plus negative 9. Negative 3x plus negative 5x is negative 8x plus negative 24 equals 4x plus negative 9. Let's get all the x's on the same side. So I will subtract 4x from both sides. Subtract 4x. Subtract 4x. Negative 8x minus 4x is negative 12x plus negative 24 equals negative 9. Let's add 24 to both sides. So on the left side, I have negative 12x. On the right side, I have 24 minus 9, or 15. Then divide both sides by negative 12. A positive divided by a negative. X is negative 15/12, which is, of course, 5/4, negative 5/4. So negative 5/4 is my cut point. I'm going to lay out a number line with negative 5/4 in the middle. I'm going to choose points on either side to see which side is going to lead me to true. So negative 5/4 is the point where they're equal. Negative 5/4 is here. Greater than or equal to solid dot. You have to think about where 0 is. 0 would be on the right side of this. 0 is greater than a negative number. Negative 5/4 is about, what, negative 1 1/4. So negative 2 and negative 3 is over on this side. Maybe I'll choose negative 3. I always like to test 0 first. So let me go ahead and plug 0 in to see what I get. So I have negative 3 times 0 plus 8 minus 5 times 0. Is that greater or equal to 4 times 0 minus 9? 0 plus 8 is 8. So we have negative 3 times 8 minus 0. Is that greater than 0 minus 9? Is that greater than negative 9? Is negative 24 greater than or equal to negative 9? Well, 24 is bigger than 9, but owing 24 is worse than owing 9, not better. So this is a no on this side. We go to the left side. What are we going to get there? Plug in negative 3. So I'm going to have negative 3 times negative 3 plus 8 minus 5 times negative 3. Is that greater than or equal to 4 times negative 3 minus 9? Negative 3 plus 8 is 5. So I have negative 3 times 8 minus 3 is 5. That's plus negative 5 times negative 3, so that'll be plus 15. Is that greater or equal to negative 4 times negative 3 is negative 12 minus 9. This is negative 15 plus 15. Is that greater than negative 12 plus negative 9, which is negative 21? Is 0 greater than or equal to negative 21? Is having nothing better than owing $21? The answer to that is yes. So we're going to shade towards negative 3, shade towards negative 3, shade this way. How far left does it go? All the way to negative infinity. Then it stops at negative 5/4. And that is a square bracket because it's a solid dot. It's a solid dot because it is an equal sign. And that will conclude this lesson.